integrating or evaluating definite intervals. So yesterday we were looking at indefinite integrals. So that meant that we didn't have any limits. We just had the integral sign. We didn't have any numbers like from 0 to 3. So we were just finding, I wouldn't call it easier. I'd call it just like a hair more. It's going to take you a little bit longer to do than the integration you were doing yesterday, but not a lot. Whenever we do these problems, what we're going to do is we are going to integrate whatever our function is that we're supposed to integrate. So in this particular case, let's see, Logan, what would we get if we integrate 4x squared minus 2? Is 4x squared minus 2. So what do we do to our exponent to integrate? We add 1, so we get 3 here. Divide out front by that exponent, so we get 4/3 x to the third. And then what about the part for the minus 2? Minus 2x. I'm going to put a plus c here. But I want you to think about whether or not it's necessary. Okay. Let's look at why it's not necessary, though. It's not going to be necessary. So, no, I did this bracket over here and put 3 to 0. Because we are going to find our f. So when we integrate, we do capital F of B minus capital F of A, right? So we integrate here, and for our capital F of B, that means we plug in 3 into our into our integrated equation. So we'll get 4/3 times 3 cubed minus 2 times 3 plus c. I put parentheses around that to separate it out, because we got to subtract what we get when we plug in 0. So 4/3 times 0 cubed minus 2 times 0 plus c. So 4/3 times 3 to the third, that's going to be in the numerator. I could cancel one of these 3's with one of these. So it's going to be 4 times 9 minus 6 plus c. This is just going to be 0. This is just going to be 0. I'm just going to get a minus c right here. And so I've got 36 minus 6. Positive c and negative c? Cancel. So I'll get 30 for this. You don't have to have the c, because they would cancel every time. You're going to have a plus c over here. It's going to end up being a minus c over on the second part. So for definite integrals, you do not have to write the plus c, because it will always cancel out. Now, if you do, they're not going to count off for it because it's technically correct, right? As long as you cancel them out, it's fine, but it's not necessary. Yes. Yes. So before, you're just finding the general formula for it. And so this is actually finding the area underneath that curve from 0 to 3. So this gives a specific area. Whereas the other integration is finding a general formula for it, not a specific area underneath the curve. Okay?
This is the perfect values.
Yes, so the other way that we know how to do this so far is we could use all that sigma notation stuff, right? That we've already probably forgotten how to do. So the sigma notation with the limit as n approaches infinity, that would also get us the correct answer here for the area underneath the curve. But this is much easier, and of course what we're going to use for anything that they give us, unless they ask us to set something up with sigma notation, in which case we might just skip it and go on. But all right, so trig rules for integration. I am not going to have you write every single one of these down. But they're basically just the opposite of our differentiation. These are in either the front or the back of your book, if you do want to go write them down. But when we take the derivative of sine, we get cosine. So if we integrate cosine, we get positive sine. So think about this. Your sines are different. So when you take the derivative of cosine, you get negative sine. But when you integrate cosine, you get positive sine. Right, because you're going backwards. So whenever you take the derivative of sine, you get cosine. But when you integrate sine, you get negative cosine. Yeah, so the signs are backwards from the derivative rules that we had. Now, we know how to take the derivative of tangent, secant, cotangent, and cosecant. We do not have derivative rules for all of those. We do not have integral rules for all of those. Because the integral rules basically just go backwards, right? So we don't know how to integrate tangent, not easily anyway. We're going to learn how to do it, but we don't have an easy rule for it. But we do know how to integrate secant squared. It would give us tangent. All right. So basically, you're taking the answer from your derivative, and if you integrate it, it gives you what you were taking the derivative of. So we can integrate secant x, tangent x. It would give us secant. We can integrate cosecant squared x. It will give you negative cotangent. Notice they kind of moved the negative over here. And then cosecant x, cotangent x, it's going to give you negative cosecant. So they are very closely related to your derivative rules. If you know your derivative rules, you should hopefully know these as well. For these.
I think we need to
Think so?
Yeah, because I need
All right.
100 and I need to learn.
Okay. Probably wouldn't hurt. We might actually do some of that at some point.
I think we should take a unit circle quiz right now.
No.
Right now. Just drop it right now. Right now. Right
We
now.
might need to.
Right now. I would take that. My grade's going to drop like that.
Yeah,
Right.
2:30 and then.
No, it's good.
Right
All right,
now.
next week sometime on any day during next week, I'm just going to pass out the unit circle and give you a unit circle quiz. Mostly because of how much you don't want to take it whenever Daniel mentions it. Makes me think we need to take one. So I'm warning you right now, sometime next week,
How much do this quiz count?
it'll count in the homework section, but it'll count,
Twice?
yeah, it counts more than just regular homework. Huh? No, we're not going to do it right now. I think there might be a few of you that would not be prepared for that. Okay, so whenever you see this, sine x over cosine squared x dx, we don't have a quotient rule for integration. We don't know how to integrate anything that looks like a fraction. So if you see something like this on your assignment, there's going to be some way of getting it to match one of those 6 integral rules that I just put up on the screen. So I'm going to write this like this, sine x. I'm just going to do cosine x times cosine x. Okay? And I should write all my other stuff because I haven't dealt with it yet. Alright, so I could make this times 1, right? That wouldn't change anything. what if I split this up where I have sine x cosine x times 1 over cosine x? Not squared, just secant x. And sine x over cosine x is tangent x. Yes. They are multiplied together. So you could, right now, they're written together, but if I write sine x over cosine x and I split it up times 1 over cosine x, it still equals the same thing, because to multiply fractions, I would just multiply the top, multiply the bottom, and it would give me what I started with. Now, tangent x, secant x was one of those things that we can integrate, right? Because if we take the derivative of secant x, we get tangent x, secant x. So if we take the integral of tangent x, secant x, we're going to get secant x. We're not done yet, because our answer, we got to plug these numbers in. But to integrate tangent x, secant x, we'll get secant x.
So wait, why do you just have secant x in the bracket?
Because the integral of secant x tangent x is secant x.
So you could say that equals secant x.
When you integrate tangent x secant x or secant x tangent x, or it doesn't matter, the integral of this is just secant.
So you could set those two things
Not equal to each other. So what I did is I integrated.
It is the integral of it, so it's equal to it.
Yeah, yes. Okay, so like I could do a string of equal signs. That's what you're saying?
Yeah.
Like this equals the line before it.
Yeah.
Okay, yes. You can. Yeah. Okay. So to evaluate this, so this is just a rule. If you ever see tangent x, secant x, its integral is secant x. Right? So we might do a quiz on it, sure enough, to make sure we know those. So we plug in pi, and we plug in 0. Okay? Secant is not on our unit circle. It's 1 over cosine. So, right here, I've got -1, 0. Over here I'd have 1, 0. Cosine is it my x or my y coordinate?
Cosine's your x.
X. So this is going to be -1. So I've got 1 over -1 minus 1 over +1. It's going to give me -1 minus 1, which will give me -2.
I don't know why I still write that.
All right, questions?
Are these rules that we're going to have to know for the AP?
Yes. Yes. Perhaps we should have a quiz on them.
Why is cheer like?
I will. But the unit circle, I'm not warning you. Except for right now, I'm warning you. Unit circle sometime next week. I won't do Monday.
Oh my God,
But
look at that
Tuesday
perfect
through
circle
Friday.
behind it.
It's beautiful.
Look at that.
I need it Monday.
That's made up.
That's
That looks like a flat
a
potato.
good circle. God.
No. But it will count more than a regular homework. All right. Okay. Here are our rules for integrals of logs.
Logarithms.
You drop them. Just walk in here right now.
Yeah. He sent me. Where's what he sent me the other day?
It's gonna be a
here. I don't know if I can. No, I want to show you what he was putting on his board the other day. This, here, I'll just have to show you on my phone. This was Coach Wood's board the other day. He was proud of it because he sent me this picture. I did not take that picture. Okay. All right. So this is going to be important for us to have. So if I'm integrating, if I take the natural log, so this is my derivative rule. We should already know it. If I take the derivative of natural log, it is 1 over x. We might have forgotten it, but we're reminding ourselves right now. Derivative of natural log is 1 over x. So when we see the integral of 1 over x, we probably don't think natural logs because natural log is not there anywhere, right? But what we would probably try to do is write that as x to the negative 1. Okay? Watch what happens if you do that. If you do that, if we try to use our general integration rule, where we increase our exponent by 1, which would make it 0, then what do we have to do? We got to divide out front by 0, which won't work because we can't have a 0 in the denominator. So, the integral of 1 over x is the natural log of the absolute value of x. Those absolute value bars have to be there because we can't take the natural log of a negative number. So if we are integrating 1 over x, we're going to get natural log. This one's easy to forget because it doesn't have a natural log anywhere in the problem whenever you're doing the problem. But when you start trying to do just the regular like power rule that we normally do, you're going to end up with a 1 over 0, and that should be an alarm in your mind telling you, wait, this was something else, right? This was not, I can't have 1 over 0, and so it should be natural log. So our question our first one's going to look like this. And so again, if we try this by making it 2x to the negative 1, we'd have x to the 0, 2 divided by 0. That will not work. So we can't use that rule here. Now, we can use that rule if it's x squared on the bottom, or x to the third, or, as long as it's not a negative 1. If it's a negative 7 as our exponent, that's fine. So we're going to think of it like this. I'm going to think of it like this: 2 times 1 over x dx. That would be equivalent to 2 over x. And so the 2 is just a coefficient. The integral of 1 over x is the natural log of the absolute value of x. And this one is not a definite integral, so we would put a plus c on the end. Yeah. Okay? All right, here's the next one. It's not that bad.
Oh, love connection.
Love connection. Yes, Selena's got it.
Totally girls' notes.
All right, so for this one, we're close to Valentine's Day here. Love connection. Triple love connection.
Whoa.
Three-way.
All right, so I'm going to write every step just so you're with me. that means we're doing 3x squared divided by x squared. You probably might skip this step. That's fine if you do. 5x over x squared minus 2 over x squared. All of that has the dx still there at the end. So that is just going to be 3 plus, I could make this 5x to the negative 1, or I could make it 5 over x. Whichever way you want to write that. And then 2x to the negative 2 dx. Are we okay there with the love connection?
How did you get the love connection set up? Like, what led you to the...
If you only have one thing on the bottom, or well, whatever is on your denominator, you can divide every term in the numerator by that
Yeah,
denominator.
but how did you get the numbers for it? Did you take the reverse derivative?
I haven't integrated all yet. I'm just dividing. So 3x squared divided by x squared. Right here.
Oh.
5x divided by x squared right here.
Another example.
And 2 divided by x squared.
Okay,
Yeah.
that's it.
We have not integrated yet.
Okay, now I was confused. I thought that we got all that example 4 from example 3.
No, this is another
This is
example.
another example.
Yeah.
That's why I was confused.
Okay. So when we integrate 3, what do we get?
You got 3 out in front and then
Okay? 3x. Just put x with it. Okay? Then, what about this x to the negative 1?
it's x to the 0. Oh, 5.
Okay, if we try that, we get x to the 0. Then we have to do 5 divided by 0. We can't do that. So this is, that x to the negative 1 is a 1 over x, right?
Yeah.
So this is going to be plus 5 natural log of the absolute value of x. And then this one, we're going to raise our exponent by 1, which will give us negative 1. We will divide out front by that negative 1, which will give us a positive 2. And because this one is not a definite integral, we need to put a plus c on the end. So whenever you have, basically, Laura, whenever you have a negative 1 as your exponent. So you're going to try to do the power rule with everything, but if you try to do the power rule with this, you get x to the 0, you have to divide out front by 0. You can't do that. That should be an alarm letting you know, wait, this was a natural log. Right, right. I mean, I don't really care, but I don't want you to be late or anything, so. Okay. All right. Exponentials. Here's some good news. They're going to be easy. Because what's the derivative of e to the x? E to the x. So what's the integral of e to the x? E to the x. Plus c.
Oh, yeah, plus c.
Yeah, so the derivative of the exponential is itself. So the integral of an exponential is itself. Which makes it, it's the only function that is the case for. Which is crazy. If you think about this, this means that the slope of the tangent line everywhere is the same as the area under the curve. Which is crazy. So, got a couple examples for us here.
No, that's not cash money.
It's not that bad.
That's not very cash.
It's not that bad. It's not that bad.
You can always tell if it's going to be long because how much space is it out between rows.
But this is the last one, so it could be short or long. Who knows? I got that extend page ready to go if I need it. Yeah.
Someone was getting on to me today about fill out my senior form for the senior night, but I won't be
Oh
able to.
yeah, he did to me too.
Because I won't be able to go. I
He
won't be able to
said
go
that I could put who knows for my last question.
Why not? That'd be classy to call out to the entire gym. Somebody let Miss Burgess in there.
I said 30.
Okay. Okay. Okay, yeah. Okay, so if we are integrating e to the x over 5, that's the same as having like 1/5 e to the x. 1/5 is just a coefficient. So when you integrate e to the x over 5, you get e to the x over 5.
Plus C.
Okay, since this is a definite integral, we are not going to put the plus c. We're going to put this bracket with the 3 to the negative 2. And so we would get e to the 3rd over 5 minus e to the negative 2 over 5.
What made that?
How is this supposed to be used? What?
Yes. Yes. Yeah.
What made it definite? What made things definite?
Whenever you have limits right here, when you have numbers.
Oh.
Okay. We are.
And then you just have to make it like
Yeah. Then all we're doing here. So what makes this easy is the derivative is the same as the integral. You don't have to change anything there. The e's are the only thing that's going to happen with. And then you're just plugging in the 3 here for this one. And then you're plugging in the negative 2, subtract the 2.
So a good way to remember this is that integrals are definite integrals are VA. They're VA.
Mhm.
V minus A.
Yeah.
So that is that error.
Okay.
That's
Yeah, they might move this back down to the bottom. I'll probably be here till about at least 4 today. So yes. It's from the textbook.
Evaluating definite integrals.
So you might see move it back down. There's a slight chance they might get common denominators there, but if it's free response, it's perfectly fine just to leave it like that. Okay? They're all gone, aren't they? All right. So for example 6, if we integrate this, 3 is just the coefficient. What is the integral of cosine? Is positive sine x. The derivative of cosine is negative sine. The integral of cosine is positive sine. You can see how that's going to be easy to get mixed up. We probably need to have a quiz on that sometime. What is the integral of 5 e to the x? 5 e to the x. And we're going to be evaluating this from 0 to pi over 2. So we would plug in pi over 2, so 3 sine of pi over 2 minus 5e to the pi over 2 minus, we would plug in 0, 3 sine sine of 0 minus 5 e to the 0. These parentheses here, separating those two, are important because since this is a negative, if you don't have those parentheses, you'll get a sign wrong on those. For response, it'd be fine to leave it like this. Usually, it's not going to be. It's going to be on multiple choice, and you're going to have to simplify. So, actually, is it fine? I don't know if they let you leave sign values there. I'm not going to let you leave sign values. So pi over 2. Yep, that's the unit circle, a really crooked one. 0, 1. And then over here, we got 1, 0. Hunter just sent me a message telling me to give him time on his iPad because they have a Bucky Buck party today. But it's 2:39. They get out at 2:35, don't they? Yeah. We're already out of school. He's not getting extra. Okay, so sine of pi over 2 is 1. We can't do anything with e to the pi over 2. Just leave it like that. Sine of 0 is 0. What is e to the 0?
1.
So basically, all you would have to do is just solve the signs, and then you guys leave it like that.
Yeah. Here you're going to get 0 here. You're going to get -5, but then you got to distribute that negative, so it's going to be a +5. So 8 minus 5 e to the pi over 2. Yes. Well, I mean, I think. Yes, it is. It's the end. Okay. Yep. Now you're gonna work on your assignment. Okay. So your assignment. Nope. You've had those test corrections for a very long time.
Very long time that I forgot.
Alright. Alright, so your assignment today is page 328, 5 through 29 odd, 37, 47, and 48. It's page 328, 5 through 29 odd, 37, 47, and 48. But you have 30 minutes. So you should be able to get a good chunk of that, if not all of it done, before you go.